most security audits find nothing. Your code base ships, customers use it, and somewhere in there is a SQL injection or a broken auth flow that nobody caught until someone with bad intentions does. What if you could run a full red team attack on your own code, automatically, before pushing to production? Helios does exactly that. It spins up 3 Claude AI agents and puts them in direct conflict with each other. One agent is the attacker. It reads your code and actively looks for vulnerabilities, injection flaws, authentication bypasses, exposed secrets, insecure API endpoints. The second agent is the defender. The moment the attacker flags something, the defender generates a patch. Not a report. A patch. Actual code that fixes the problem. And the third agent? That's the referee. It scores both sides, validates whether the patch actually closes the vulnerability the attacker found, and logs the result. Let's be concrete about what a real run looks like. You point Helios at your repo. The red agent starts reading through your files, controllers, models, API routes. It finds, say, an unsanitized user input going directly into a database query. It reports this with a severity score and the exact file and line number. The blue agent receives that report, writes a parameterized query replacement, and submits it as a code change. The referee agent then evaluates, does this patch actually close the vector the red agent exploited? If yes, it marks it resolved. If the patch is incomplete, it flags it for another round. This all happens without you writing a single test case or manually reviewing anything. You get a structured report at the end, vulnerabilities found, patches generated, which ones passed referee validation, and which ones need human review. But here's the thing, this is not a magic shield. Helios has real limits you need to understand before you trust it with anything critical. First, it's only as smart as the context it receives. If your codebase has complex multi-service interactions, a vulnerability that only appears when service A talks to service B under specific race conditions, Helios will likely miss it. It reasons about code statically, not dynamically. It's not running your application and watching it behave. Second, the patches it generates are not production ready by default. They're starting points. The blue agent writes code that closes the logical gap, but it doesn't know your team's conventions, your test suite, or your deployment constraints. You still need a developer to review every patch before it goes anywhere near a merge. Third, it's currently built around Claude specifically. That's a paid API. Running Helios on a large codebase will cost real money per session. There's no local model fallback yet, which means this isn't free to operate at scale. And fourth, the referee agent is also an LLM. It's judging patches using language model reasoning, not formal verification. It can be wrong. A vulnerability could be marked resolved when it's actually still exploitable. You cannot treat the referee's verdict as ground truth. What surprises me is how close this already is to being genuinely useful in a CI/CD pipeline. Imagine this, every pull request automatically triggers a Helios run. Before any human reviewer even opens the diff, the red agent has already probed it, the blue agent has suggested fixes, and the referee has flagged anything that failed. The developer opens their PR and sees 3 vulnerabilities found, 2 patched and validated, 1 needs manual attention. That's a completely plausible near-term workflow. If the project adds support for local models, something like a self-hosted Llama or Mistral variant, the cost problem disappears for teams that can run inference on their own hardware. That would make this viable for open-source projects or smaller studios that can't absorb per-token API costs at scale. There's also an interesting direction here for compliance-heavy industries. Healthcare software, fintech, anything that has to produce security audit trails, a logged, structured red team report generated automatically every sprint has real regulatory value, even if the patches still need human sign-off. So why does Helios exist? Because the traditional alternative is expensive and infrequent. Hiring a penetration testing firm costs thousands of dollars per engagement and happens once or twice a year if you're lucky. Internal security reviews are inconsistent, they depend on who's available and how much time they have. Static analysis tools like SemGrep or SNYK catch known patterns but don't reason about novel attack surfaces. Helios sits between automated linting and full human red teaming. It's faster than a consultant, cheaper per run than a firm, and it reasons about your specific code, not just known CVE patterns. It's not replacing your security team. It's giving every developer on your team a sparring partner that argues back. Helios is early. The scaffolding works, the adversarial loop is real, and the concept is sound. Whether it becomes a standard tool in the security pipeline depends on how reliably those referee decisions land and whether the patch quality improves. That's the experiment worth watching. If you want to see what happens when we run Helios against a deliberately vulnerable test application, full output, every agent's reasoning, every patch, that's the next episode. Subscribe so you don't miss it.